All right, so our next topic states that water is amphoteric. What does that mean? Let's go ahead and take a look at some of the reactions that we previously looked at. So we looked at ammonia, NH3, reacting with water to form ammonium, NH4 plus, and hydroxide, OH minus. And then we looked at hydrochloric acid, HCl, reacting with water, H2O, to form H3O plus, that's hydronium, and a chloride ion. And then we labeled our acids and our bases, right? Over here, we said that this water was acting as the acid because it donated the H plus. Over here, we said that water is acting as the base because it accepted the H plus. And so that's what amphoteric means. Amphoteric means that it can act as an acid or a base. It just depends on what it's reacting with. So sometimes water acts as an acid, other times it acts as a base. You have to take a look at the chemical reaction and identify whether that water is accepting H plus and then becoming H3O plus, or if it's donating the H plus and then becoming hydroxide. All right, so whenever we write reactions, especially in general chemistry, our most common solvent is water, right? That's the most common solvent that we work with. And so sometimes we just omit it. So sometimes water is omitted, which means that we just don't write it out in the chemical reaction, but we know that it's still there. So for example, with acids, sometimes you'll write HCl with an aqueous, right? That means that it's dissolved in water, just breaking it into H plus Cl minus, right? So when you write this, what you really mean, what's actually really going on in your reaction is that the HCl is reacting with H2O to form H3O plus and Cl minus, right? So a couple of things here that we have to note is that this H plus and H3O plus are equivalent. When we're talking about an aqueous solution, right? So you can write it as H plus or H3O plus. As a chemist, we both know that you're talking about the same thing. Again, this H plus is usually just called H plus or a proton. H3O plus gets the special name hydronium. So sometimes you'll hear hydronium ion. But again, right, these little aqueous symbols tell you that you're in water, and there's your water right there. Same thing with bases. Sometimes we omit the water. This one's a little bit kind of, I guess, sometimes more easy to see, sometimes more difficult to see. So for example, sometimes you'll just write as NH3, that's a base in aqueous solution, just becomes NH4 plus OH minus. And so the question is, well, on the left side, we have NH3. On the right side, we have OH minus, and then an extra H and an extra positive charge, right? So where the heck did these come from? If you try to balance this equation, it's impossible because we have no oxygens on the left side, right? And where it came from was the water. That's just implied, right? It came from H2O, right? So again, we're just omitting it just so we can keep things more brief. Really, when we write this top equation, what we mean is NH3 plus H2O becomes NH4 plus OH minus, and then boom, now the equation is balanced. So just something to keep an eye out for.